Start recording now. And so for yung problem 3 which people have struggled, make sure makover na lahat ng cases. So usually yun yung problem with uh, proof by cases. Baka hindi mo makover lahat ng cases, so hindi complete yung proof mo. And then the thing here is absolute value. So, well, for me, usually pag absolute value ng problems ang ginagawa ko siyang piecewise. When x is positive, x is just equal to x. When then x is negative, x is equal to negative x. So, you can check siguro for cases, positive si x, positive si y, negative si x, negative si y. Although, yung mahirap dun, madadagdagan pa tayo ng cases whenever x is greater than y or y is less than x. So, in this specific problem, I think pwede nyo gamitin yung number line. So, if you can visualize yung number line, we add the paint. And then, I'm going to judge yung aking paint skills. Let's say it's 0. Let's say si x nandito, si y nandito. So what actually happens when we do an absolute value? So si y, mapupunta lang siya dun sa same spot dito. So we only care about yung actual value ni y. So hindi natin masyadong pinapansin. Or, I guess baka mas nagmamatter yung magnitude instead of yung sign. And then yun. So this is the case na different si x and y. And then y is less than x. So pag nandito naman si y lilipat siya over there sa malayo. And then, if ever same side sila, basically wala kang babaguhin masyado. Wala nagbabago masyado. And then, kung parehong, if x and y is parehong nandito, then I guess, same lang siya dun sa case na yung x and y parehong nandito. So, maybe something to take note doon. So, baka makaya nyo i-reduce yung number of cases na kailangan nyo check. And then, ayan. So, hindi din ako makapagbigay ng masyadong hints kasi baka masyadong iba-iba rin kasi yung per person na submission. So, mas maganda if we know what you know and then we'll work on that para makita namin kung paano kayo tutulungan. Kasi lalo na dito sa proving, there's not just one solution for everything. So, we will work on what you have. So, please do submit kahit sure kayong hindi pa siya complete correct. And then we'll be giving feedback naman on your submission. So, ayan, parang naging iterative process siya, kumbaga. Parang, and yun din, all of our submissions na graded will have unlimited number of tries. So, yung pinaka-limiting factor nyo lang dito yung time. So, syempre, kailangan, if magsasubmit ka ulit, mag-devote ka ulit ng time for it. So, yung main challenge lang sa inyo, no, yung pinaka-time management nyo. So, if ever given ka ng isang score, gusto mo pa bang better the score, kailangan pang mag-allot ng time. Otherwise, yun, pwedeng mag-submit na mag-submit. Then, parang similar din yung kasi sa case, pag kumari face-to-face na classes, most of our exercises, lalo na sa 1-to-1, medyo ganun yung setup. Papakita yung problem sa inyo. You solve on your own or with a group, with a pair. And then, if may answer kayo, magtataas kayo ng kamay, ako or yung SA lalapit sa inyo, will check your answers. And if mali, may chance pa kayo magpalit or may chance pa kayo mag-improve ng sagot nyo. So parang gusto namin i-emulate yung ganong situation with or in ganong setup with our situation right now. Kaya we opted to give unlimited number of tries. Sa inyo na lang kung willing kayo mag-devote ng time for that. Yeah. So, yung sa ginawa ko kasi kahapon, I have one exam. Dinaanan ko tong isang example dito and we proved it. So, medyo madali lang naman siya. So, I have two functions, square 1 at square 2. So, pag nirun mo to sa Python, pareho lang yung sagot nila. And then, basically, itong square 2, at first glance, hindi siya mukhang function that returns the square of a number. So, ayun nga, yung function 1 is, sure ba tayo tama to? Of course, since Python is programmed or is instructed pag makita niya to, gagawin niya yung squaring operation. So, medyo iba siya dito pero same thought. So, medyo trivial yung pag-prove sa kanya kasi definition na siya nung operation. So, for the second function, medyo hindi straightforward. So, I guess some of you nakita na yung video kahapon. So, baka familiar na sila sa proof na to. Although gusto ko pa rin daanan just to, para lang if ever meron mga sa inyo hindi siya nakita, medyo maging familiarized dun sa process. Well, yung process naman na to, medyo specific siya sa akin. As in, we might label steps differently among other instructors, lalo na sa materials. Pero yung overall, yung nangyayari is pareho lang. So parang nag-iiba lang yung labels. So, in my case, yung first step is to prove that the function terminates, or baka kasi may loop tayo dyan, infinite loop siya. So there's no point in proving or trying to know what an infinite loop does. And then yung next is identify a useful loop invariant. So a loop invariant, based on the name, hindi siya nagva-vary at each iteration ng loop. So for example, pinlay ko yung program and nagra-run siya sa aking processor. At any point in time, pag pinos ko yung pag-replay niya, this loop invariant should still remain true or parati dapat siyang nandun. I think by example later, mas may kita nyo anong ibig sabihin nun. And then, so step 2 kasi, this is more of a hypothesis. You have a guess kung ano yung loop invariant. And then sa step 3, ipoprove natin na yung loop invariant is invariant na, or basically it is an actual loop invariant. Kasi most of the time sa step 2, hula pa lang siya. So kahit hindi tayo sure actually doon sa sagot sa number 2, okay lang. We'll find out naman later down the process. And then, of course, yung loop natin natatapos. Once we prove the loop invariant, it doesn't stop there. Yung loop invariant just focuses on the loop. So what does the actual algorithm do? So dun pumapasok yung last step wherein we evaluate or show ano yung value ng loop invariant when the loop terminates. So basically, yun dito. Yung proof of termination, medyo trivial siya kasi in the way Python for loops are defined, parati siya mag-terminate kasi laging finite amount of digits or finite amount of elements lang naman yung isang range. So lagi naman siya mag-terminate. So it makes sense to move on to the next step. So a possible na loop invariant, ci less than a. So at any point na ba nagra-run yung algorithm na to, I will always be less than a. So it's a loop invariant. So, and actually, yung sinabi ko na yun na yung pinaka-proof kung bakit siya loop invariant. since si range A it has only elements from 0 to A minus 1, so I will always be less than A. Although, paano natin nasabing hindi useful to? Kasi at termination, ano sinasabi sa atin nun? I is less than A. Wala akong idea kung ano yung value ng temp. Ano yung nire-return ng algorithm ko. So, yes, loop invariant siya, pero it's not that useful. So, another loop invariant is actually mag-copy paste or mag-copy ka lang ng any statement doon sa loob ng loop is actually a loop invariant. So, at any point in time, temp will be always equal to temp plus this value over here. So, since ganun natin siya define, yun yung definition ng function, it is a loop invariant talaga. However, sa dulo, given this, knowing this, parang wala tayong masasabi about the result ng temp. Ano yung final value niya? Knowing this as a loop invariant ba, parang nakikita ko ba kung ano yung result ng algorithm? So, I guess i-gloss over ko na lang yung steps dito. Pero what this basically says is, I think, based on observation, pag i-list down ko yung values ni temp given an I, parang yung value ni temp is always I plus 1 squared. So parang, di ba? So pag 0, 1 siya. So 0 plus 1 squared, 1. Pag 1, 4 siya. So 1 plus 1, 2. 2 squared is 10. So it looks true. So let's say it is our loop invariant. So at this point, parang hindi pa tayo sure. Which is why we have yung next step, which is yung proof by improving the loop invariant. And usually, since loop to, we use induction. Kasi when we use induction, andito na yung base case natin when we try to visualize what the loop does. So at I equals 0, temp is indeed I plus 1 squared. So next is kailangan natin tingnan yung inductive step. So sa inductive step, we need to show that yung next value ni temp is equal dun sa next value ni I plus 1 squared. So mostly math lang naman to. And then, di ba, when we do proof by induction, we can assume that yung original na temp equal na siya sa I plus 1 squared. So, excuse me. So if you want to show this at the next iteration, we know by the definition ng function, yung next na temp is yung original na temp plus 2 times I next plus 1 na yung base dito sa line na to. So si temp na next, wala pa tayo masabi. Yung previous na temp, because this is proof by induction, we can assume na equal siya sa I plus 1 squared. So sa next line dito, si temp, ginawa ko siyang I plus 1 squared. And then si I next, alam natin, within a for loop, and then in for loop over a range, yung next na I value ko would be I plus 1. So, ito, arithmetic lang, if expand ko both terms and then combine like terms, makakuha ko ng I squared plus 4I plus 4. And that will be equal to I plus 2 squared. I plus 1 is I next. So, I plus 2 is equal to I next plus 1, which is what we wanted to prove in the first place. So, we say na, okay na yung inductive step natin. We have proven that si temp equal nga siya sa I plus 1 squared at any point in the loop. So, ang final step is the termination value. So, yung for loop natin, ang final value ni I is A minus 1. So, when we plug in A minus 1 dito, we get temp is equal to A squared. So, at the end of our analysis or at termination, we can say yung result ng algorithm natin is A squared. So, I think nung tinignan ko yung materials na given dun sa yung common materials natin, Yung base case ng proof by induction is called the initialization step, and then in inductive step, tinatawag din siya yung maintenance. So basically, same lang naman din yung premise nila. So yung initialization is i-evaluate mo siya at the starting values ng mga bagay-bagay, which is in this case, I equals 0. And then yung inductive step or yung maintenance is the same. And then yung termination is yung last step pa rin. So, ayun. So, for yung class kahapon, yung naging example ko is yung sieve of Eratosthenes. So, medyo mabigat siya on arithmetic. So, I figured, for example, for today, magpo-focus siya more on strings. So, medyo simple lang. Hindi siya kasing fancy nung kahapon. May special name yung algorithm. Example ko lang for today will be finding a substring in a string, basically. So, I think I have it open. So, VS Code. Let's see if mapakita ko yung example. So, I have yung find string dito na defined. And actually, si long and short, actually keywords sila. Pero in this case, kaya naman silang i-override. So, okay lang. So, in this call, nag-call ako ng find string. Yung long string ko is just A, B, C, D, E, F, G hanggang P. And gusto kong mahanap si E, F, G dun sa string. So, when I run the program, ang mapiprint out na value is 4. Kita niyo ba? So, yung result ng terminal ko when I call it is 4. Kasi at index equals 4, so 0, 1, 2, 3, 4, doon nagsa-start yung EFG na term. So, how do we prove na it works? Similar dun sa kahapon, since we are dealing with two loops dito sa loob, we start with the innermost na loop. Because yung innermost na loop, yung kung ano yung mapoprove natin na ginagawa ng innermost na loop, will be useful for us when we go into proving yung buong algorithm. So let's just bisitakpan natin yung other parts na hindi natin gustong pansinin right now. And so focus on the inner loop. So proof of termination. So we have two cases. So either j plus j or yung counter natin increases, or the loop breaks whenever hindi na satisfy yung condition na to, whichever condition it may be. So in both cases, we'll be sure na the loop will terminate. So, okay na tayo sa step 1. So next step is identifying a loop invariant. So, I guess yung uh, pinaka-advice ko when identifying a loop invariant is to visualize kung ano yung ginagawa ng algorithm. So, in this case, let's say ito si long, ito si short, and then ICO starts at somewhere here. Diretso na tayo sa C para medyo mas may sense yung discussion. So, when I is equal or yung I value ko is equal dun sa index ni C, and then J will start at 0. And then while J is less than yung length ni short, so basically while si J naka-point pa rin siya sa loob ng loop, i-check ko if long I plus J, C equal ba siya kay C over here. If equal, mag-add 1 ako kay J. So, gumalaw si J to the right. Then, next instance, when we check si J within boundaries, and then we check yung element at I plus J, which is in this case D, and compare it with D over here. So, since pareho, we proceed, mag-add 1 kj, and then, ayan. So basically, another round nun, since si E equal kay E, sa next iteration, si J hindi na siya papasok dun sa loop. So, basically, di na tayo papasok dun sa while loop. And then, si I plus J nakaturo na kay F. So, medyo wala naman tayong sense or wala na tayong masyadong pakialam doon. Although, what if si short hanggang G siya? So, ayun. Dito kasi nagmumukhang si short nakikita natin kay long. Pero what if meron isang letter na hindi pareho? Ang masasabi lang natin, yung short hanggang kung saan nakaturo si J, yun lang yung sure tayo na pareho. So, in other words, uh, yung loop invariant natin is that long from I to I plus J, pareho siya doon sa short from 0 to J. So hopefully familiar pa naman kayo sa mga slices sa Python. If kailangan ng konting refresher doon, again. So let's say we have a string 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So pag kunin ko si S from 0 to 5, makukuha ko si 0 hanggang 4. So hindi kasama yung last digit dito. Then if I start it from 1, magsa-start sa 1 yung result. And then if tanggalin ko yung isa, pupunta siya hanggang sa dulo. Tanggalin ko yung sa start, whichever is yung first element, hanggang kay 5. So, basically, daanan lang natin sandali. So, ang sinasabi nito, I to I plus J equals siya kay short, 0 to J. So, that would be consistent dito sa last case natin na I to I plus J. So, hindi kasama yung last element is equal to start ni short hanggang kay J. So, which is true. So, we have reason to believe na this might be a viable na loop invariant. So, yeah. Reminder lang ulit, exclusive yung dulo, inclusive yung simula. So, yeah, we have a possible na loop invariant. We just have to prove it. So, at the base case, when J equals 0, yung statement na to just simplifies to long I colon I, short 0, 0. So, pag same yung start and same yung end, since exclusive yung end, medyo mas susundan na yun. So, pag nilagay ko dito S 0, 0, the result niya is an empty string. So, an empty string, since pareho silang empty, equal sila. So, yung base case natin is true. So, ayan, since both are empty, they are equal. So, yung next step natin is to, yung inductive step natin in proving the loop invariant. So, we need to prove that I is long, starting from I hanggang I plus J na bago, equal siya from 0 to J na bago. So, rewriting that, basically, we need to prove this statement, assuming that this is true, since this is proof by induction. So, notice that meron tayong if statement sa while loop natin. So, we have to consider two cases. Whenever pumasok tayo sa loop, or whenever this is true, which is just case number 2 dito, or yung additional case na dito tayo sa baba. Excuse me. So, ayun. So, usually pagka may if statement sa loob ng loop, you usually go to basically proof by cases na siya. So, yung inductive step natin is pinoprove natin using cases. And then, yung converse, yung complement naman nito is this. So, we're sure na pag na-cover natin yung both cases na to, we cover all cases naman na. So, yung first one, medyo simple lang. Pag dito tayo dumaan, pupunta tayo sa break. So, walang magbabago kay J. So, yung bago nating J is still J. Hence, in this part, ito, initial statement natin, may equal lang siya dito sa assumption natin. Since this is something we assume true, the loop invariant is still true for this case. So, pwede tayo mag-move on dun sa case 2. So, for case 2, yung bago nating j is j plus 1. So, we need, so pag ginamit natin si j plus 1 dito, or actually dito muna sa umpisa, it means na it's long from I to I plus j plus 1. Or I to I plus j plus si long at I plus j. So, what this basically means is kung ano man yung original natin, dinagdagan natin ng isa pang element. And that particular element is yung nasa dulo nung naunang list. So, going back dun sa visualization kanina, si I to I plus j is just this, yung CDE. And then, yung element at I plus j, si F, idadagdag natin siya dun sa original na list. So, yun yung sa long. And then similarly sa short, since gusto natin i-prove ito, so in order to prove, gusto natin gamitin ito, or gusto natin siya expand basically para mapakita yung assumption, yung part ng assumption natin. So, you may have noticed sa proof by induction, gusto natin mapakita yung assumption natin doon sa pinoprove natin na or doon sa next iteration. So basically, yung given yung statement dito sa taas, kailangan mapalabas natin somehow yung statement na ina-assume natin na tama, which is yung ginagawa dito. So 0 to j new is just 0 to j plus 1. And then yung 0 to j plus 1 is just 0 to j plus yung element at j. So hopefully nasusundan pa ako. So direct ko lang. Since si long I plus I to I plus j new, equal lang siya dito. Then si short, equal lang siya dito. I-rewrite lang natin siya. Yung concatenations basically ng list. And notice that ito is this statement over here. And then ito is this statement over here. So since alam natin na equal sila by the inductive assumption, parang basically pwede sila mag-cancel out. So kailangan lang natin i-prove na equal si element at I plus j ni long and yung element at j kay short. Looking back, ito yung specifically case na tinitignan natin ngayon. Whenever long I plus j is equal to short at j. So we know that this is true kasi yun yung initial na condition natin kung bakit tayo nandito. So, ayun. So it is trivially true because it is the case we are considering. Therefore, si case 2, or for case 2, we have proven that yung next iteration or yung ating loop invariant is still true. So, okay na tayo for both cases. So, okay na yung proof natin sa inductive step. So, that is proving the loop invariant. So, what that tells us is, so this loop invariant we chose is actually true. Pero yun nga, yung next step natin is so now what? Alam natin na true siya, anong ibig sabihin nun? So, at termination, actually, may dalawang cases din tayo. Yung first case is when j equal siya kay length ni short. So, basically, that's when for all elements ni short, dumaan tayo sa j plus equals 1. So, at this termination value, ito, short 0 to length ng short is basically the whole string, short. So, at this termination value, we can say that long, pag sinlice natin siya from I to I plus j, we get yung short. So basically, nahanap na natin yung substring natin kay long. and it starts at I. So long. So basically, it contains the word or it contains the substring short. Sa other case naman, when j is less than length ng short, or ibig sabihin, dumaan tayo sa else block na to, basically yun, yung inverse lang, long I to I plus j does not contain short. So, ang medyo tatandaan lang natin dito is if ito, it nagta-terminate yung loop natin with this, and then if j is equal to then the short, yung length ni short, our loop terminates and results to this one. So, pwede na tayong mag-move on dun sa rest of the algorithm or yung outer while loop. So, proof of termination, here yung loop natin ay always increments by 1. So, eventually, magiging mas malaki siya dito, and so eventually, magto-terminate yung loop. So, how do we identify a loop invariant for this one? Ayun, going back, we visualize it. So, initially, I is equal to 0, and then papasok tayo sa loop, and then dadaanan natin yung inner na for loop. So, di ba nga, ang conclusion natin kanina, ang ginagawa lang ng while loop na to, basically inaalam niya kung si short ba ay nakay long starting at I up to yung length ng short. So, since we didn't find short doon sa, since three characters si short, so yung first 3 characters ni long, or yung 3 characters ni long after I, hindi sila part or hindi sila equal kay CDE, alam natin na, ay nandito pala. So, pag nag-terminate yung loop natin, either j is equal dun sa length or j is less than the length. So, since hindi natin nakita si short, j will be less than yung length ng short. Therefore, yung if statement natin dito, will be false. So, mag-increment si I. So, notice there how we used yung, ito yung terminating condition or basically yung conclusion natin dun sa inner na for loop. And it is what we use to define kung ano yung nangyayari doon sa outer na for loop. So, parang hindi na natin, kahit hindi na natin daanan ito step by step, parang it provides us a shortcut, basically. So, yun nga, mag-increment si I. And then, since dito, si BCD hindi siya equal kay CDE. So, si J will be less than length ni short. So, pupunta pa rin tayo sa I equals I plus 1. Now here, since nakita natin si short, CDE equal siya kay long, si J will be equal to the length ni short. Therefore, mag-break na tayo sa loop. So, lalabas na siya. So, anong ginagawa ng loop? So, basically, nag-increment lang si I hanggang mahanap natin si short. So, in other words, kumbaga, ang loop invariant natin would be describing that. So, short can only exist in long, starting from I hanggang dulo. Otherwise, if hindi siya mag-exist from I hanggang dulo, hindi siya nag-exist at all kay long. So, actually, kulang yun. Yeah, it does not exist in long. Just let me as the next slide. So, basically, sinasabi lang nun, when we, something to remember then, when we read the loop invariant, ito lang yung ina-assume or apart doon sa nakikita natin sa ginagawa ng function, ito lang yung parang i-assume natin na tama. So parang hindi natin, wala tayong alam about the other parts ng long natin, basically. So may information tayo, basically, about doon sa substring ng long na to, starting from I. So, maybe when the time comes na mag-check kami ng mga loop invariants, I think may kita naman namin yung ganung problem sa ibang tao minsan na may assumption sila na ganito, may extra assumption sila na ginagawa. Well, ipo-point out naman namin whenever you do it kasi medyo mahirap siyang i-describe for now. Anyway, moving on. We have a loop invariant that we want to prove. So initially at the base case, I equals 0. So when I equals 0, this statement becomes long starting from 0. So long starting from 0 is the whole string. So if short would exist, then it would exist somewhere in the whole string. So the base case is, or the loop invariant is true, or the loop, or this, yeah, the loop invariant is true at the base case. So now dun tayo sa next step, which is yung inductive step. So we need to prove that short can only exist in long, I next. Otherwise, it does not exist at all dun kay long. Sorry, hindi siya cache. So, since wala ng space, i-rewrite lang natin siya. Ayan, so prove that short exists in long, assuming short can only exist starting from I this time. Dito I next. Ayan. So yeah, since meron tayong for loop dito sa baba, we again have two cases. So sa first case, j is less than or equal to length. And in this case, pumupunta tayo sa I plus equals 1. So I next is equal to I plus 1. And then we need to prove that short can only exist in long starting from I plus 1. So basically, nag-remove tayo ng isang index. So because of the inner loop, we know that long I to I plus j does not contain short. Since yun nga, 'di ba, may dalawang terminating conditions yung ating loop. Pag j is less than short, short is not found. If j is equal sa length, short is found. So in case na tinitignan natin, j is less than short. Okay, strictly less than. We know that long I to j, I to I plus j would not contain yung short. So because of that, yung first element dito will not be equal dun sa, or basically, actually kahit hindi natin record, kasi minsan maging true to. So given the statement alone, since hindi siya magko-contain ng short, I, yung first element ng long will not be the first element ni short doon sa list. Basically, if ever mag-exist man si short sa slice na to, hindi siya magsa-start at index I. So, yun na yung gusto kong sabihin dito. So, hindi naman necessarily hindi equal. So, pwede equal, pero hindi siya yung start nung short. So, because of that, ayun nga, ito basically gusto ko sabihin. So, if short would exist dito sa dito, log I would not be a part of it. Or actually, if short would exist dun sa slice natin, hindi magiging part si index I because of the information we get dun sa termination ng inner loop. So, we say then na we say then na okay na yung sa first case natin. Now, yung sa second case is much easier. When j is equal sa length ni short, si I, wala tayong babaguhin sa kanya. So, since hindi nag-change si I, and then yung I lang naman yung medyo nagmamatter dito, basically yun. Similarly kanina, dun sa case na hindi tayo nag-increment, since I next equal to I, and then yung inductive assumption natin is there, therefore di natin siya, well, trivially true lang naman siya, basically. So, in fact, additionally, this case means that short has been found and it starts at index I. Pero mas useful, mapapakita natin sa termination, wherein we have two different scenarios kung kailan siya mag-terminate. So, yung first scenario is when I is equal doon sa length ni long at saka length ni short. So, basically, hindi na natin na-satisfy yung condition ng loop. Yan, plus 1. So, ibig sabihin nun, si long starting from I would be shorter than short. Kasi, ayan, basically, hindi na siya kasha. So, short cannot exist in something smaller than itself. So, short does not exist in long, which is yung parang second case natin dito. Either short can exist sa kanya or it does not. So, which is unexpected naman. So, hindi natin siya nahanap, basically. And then when j is equal to length ng short, nag-terminate tayo because of this condition. Yun, nahanap natin si short. Kasi yun yung papasok lang naman tayo dito when this terminates with j equals length. And then we concluded earlier that when j is equal to length ng short, nakita na natin si short. So basically that's the end no analysis no function na ito. So may questions ba? Hopefully nasundan nyo. Yeah, so may nag-isang wala. So I'm hoping nasundan nyo naman. So a couple of reminders. Kahit hanapin nyo man, walang week 5 between week 4 and week 6. Kasi Holy Week next week. So medyo pahinga siya for you, or in another case, baka time for you to make habol or pahinga or paghabol ng requirements. So, and then also i-release din next week yung problem set na magiging due sa hindi naman sa reading break itself. So, after ng reading break nyo kasi there are about 3 more days before the weekend. So, doon nyo isasubmit yung problem set nyo. So, ayun, after ng release ng about week 5, we have 1, 2, 3 weeks for the problem set. And I think the problem set consists of 3 separate problems or 4. So, ayun, supposedly, per week dito, makakatapos kayo ng one part ng problem set. And then on the week of the submission, tsaka nyo gagawin yung last part. So, wag nyong try gawin yung problem set ng isang week lang. Baka ma-burn out kayo. So, ayun lang naman for now. Well, yun naman, yung quote-unquote deadline no problem set is not really a hard deadline. So, pwede kayo mag-submit after nun. Wala naman deductions. Pero as much as possible, mag-submit kayo during the problem set kasi during the suggested na date. Kasi magpo-proceed na tayo sa weeks 10, 11, and 12 irregardless kung tapos na kayo sa problem set. So, baka mabaon kasi kayo sa requirements. So, ayun. Next week, medyo buffer week siya. Enjoy the holidays. Yes. Ang alam ko, multiple attempts ang prob set. So, pwede kang mag-resubmit if hindi ka pa happy doon sa grade mo. Yung submission nga will be similar doon sa may submission bin siya. So, isa-scan nyo and then check namin. So, yun din. Because during the problem set, wala rin kaming i-release na bagong yung bagong assessments, mas madali for us to give our feedback agad during the specified na week. Kasi yun nga, uh, walang ibang gagawin for us din naman. So, ayun. Kasi consider nyo rin if magsasubmit kayo kung gaano kami kaaga makakapagbigay ng feedback. If wala pa kaming chine-checkan for weeks 10, 11, and 12, mas madali namin ma-checkan yung problem set nyo. So, incentive sa mga gusto magpasa ng maaga. So, yun. Any other questions? Yeah, so may nagtanong if magre-resubmit, i-edit lang ba yung submission? So, from what I know, kunwari sa week 3, hindi ko lang sure kung makikita ko yung buttons. Kasi parang may add submission kayo, di ba? Or may edit submission kayo. And then, if graded na kayo, actually kahit hindi naman graded, pwede nyo baguhin yung submission nyo. So, pwede rin yun. Yun, so i-edit nyo nga lang and then save nyo ulit. And then, try to put a comment or send us an email na nag-resubmit kayo para alam namin na titignan namin siya ulit. Kasi, since wala na yung button before, since free na kayo to edit your submission, mas mahirap sa amin ma-notify if binago niyo yung submission nyo. So, ayun, edit nyo lang and then you have to notify us if hindi pa namin siya nire-recheck again. So, I think meron naman kayong option to add a comment. I think that's enough for us. Nakikita naman namin. Anything else? Wala. So for yung Wednesday, Friday section, since 1 or 2 p.m. kami natatapos after ng class lunch. So after ng class natin ngayon, I guess, merienda tayo guys. Kasi if wala ng questions or if meron man kayong bagong questions na maisip, nandiyan yung Discord, nandiyan yung emails. So maraming salamat sa pag-attend and enjoy your merienda if meron man. Bye-bye.